Okay, so the next one would be least recently used or LRU. Okay, so the prediction behind LRU or the least recently used algorithm is that the page has not been used in the longest period of time is the one that will not be used again in the near future. Okay, so note that the distinction between PIFO and LRU, the former looks at the oldest load time and the later looks at the oldest use time. Okay, so some view LRU as analogous to optimal or OPT, except looking backwards in the time instead of forwards. Okay, so figure here, okay, illustrates LRU for a sample string. Same sample string is given or reference string is given. So this yields to 12 page faults. Okay, so how do LRU operates? So again, initially all these frames are empty. So plotting 7, 0, and 1. So when there is no free frame, then we have to choose the victim. So the victim frame, okay, so this is the opposite of optimal, wherein you have to refer on the previous pages. Okay, so it says here, replace the page that has not been used in the most amount of time. Okay, so that means the recently used pages should not be replaced. Okay, so in that case, we just recently used 1, we just recently used 0, and therefore the least recent used was 7, so replace 7 with 2. Alright, so 0 is allocated, we need to allocate 3. Again, who's the victim here between these 3? Alright, we cannot replace 0 because it is the recent used, right? Most recent. Followed by 2. So 1 is the least recent used. So therefore, we need to replace 1 with 3 here. Alright, so allocate 0. 0 is already allocated. Next is to allocate 4. Alright, so 0 cannot be replaced, 3 cannot be replaced. 2 was the least recently used. So therefore, you replace that with 4. Alright, so next would be allocating 2. 4 cannot be replaced, 0 cannot be replaced. These are the 2 recently used, and the least one would be 3. Replace that with 2. Okay, next is to allocate 3. 2 and 4 is the most recent, so therefore 0 is the least, so therefore replace that with 3. Alright, so allocate 0. Okay, so allocating 0, 2, and 3 should be there. 2 and 3. So we need to replace 4. 3, 2. Okay, allocated, we need to allocate 1. So 2 and 3 should not be replaced. You've got 2 and 3 there. So therefore 0 should be replaced because that would be the least recent used. So you've got 1 there. Alright, so next, 2 is already allocated. Allocate 0. 2 and 1 should be not replaced, so we need to replace 3 with 0. Plot 1, allocated. 7. 1 cannot be replaced, 0 cannot be replaced, so it is 2 that needs to be replaced with 7. Okay, and this would yield to 12 page faults. Alright, so 12 page faults for optimal we have 9, and for the first come first serve you've got 15. So it shows that among these 3 algorithms, optimal seems to be the best algorithm, but again in reality, so optimal is not being used because it includes foretelling, all right, or we cannot really see the future, so that's why it is just used for comparison.